Listed in the Almagest, a star catalogue written by Ptolemy around AD 150, Alpha Centauri was documented in antiquity and has always been an object of curiosity for astronomers. Despite it being documented so early, it was not until the late 1600s when the astronomers realized that it was a multi-star stellar system, meaning it was made up of 3 stars: Alpha Centauri A, Alpha Centauri B, and Alpha Centauri C. Our universe is a vast and mysterious place, full of secrets waiting to be unveiled. Sure, our world, in fact, our entire solar system revolves around the only star visible to our eyes, the Sun. However, at the very doorstep lies our closest neighbour, the Alpha Centauri System. The multi-star system is not only the closest star system to our solar system, but it is also surrounded by mysteries along with many unanswered questions. One of them is the possibility of extraterrestrial life in the Alpha Centauri System. It's thanks to the work of astronomers like Robert Innis, who made significant contributions to the study of astronomy and helped unlock some of the universe's secrets. Innis was a South African astronomer who worked at the Union Observatory in Johannesburg. In 1915, he made a groundbreaking discovery: the faintest star of the Alpha Centauri system, which he named Proxima Centauri. He detected a slight wobble in its position using advanced telescopes, which he suspected was caused by the gravitational pull of an orbiting planet. This was an early indication that exoplanets might exist and could be detected through their influence on the motion of nearby stars. Innis and his team continued to study the Alpha Centauri system, hoping to unlock more secrets about its composition and behavior. They calculated its distance from our solar system and sought to resolve where the planets orbited the star system. However, it wasn't until 1992 that the first confirmed exoplanet was discovered. The detection of a wobble in the star's position remains a common method for exoplanet detection today, but the study of Alpha Centauri is far from over. In 2012, astronomers were able to prove the existence of a planet in the Alpha Centauri system thanks to advancements in technology and observational methods. The discovery of this planet, called Alpha Centauri B, opens up new avenues for the search for extraterrestrial life. Although whether it improves the likelihood of discovering life outside of our solar system remains unclear. So why is the study of Alpha Centauri so important? For one, it's the closest star system to our own, making it a prime target for further exploration and study. Additionally, Alpha Centauri is a binary star system, meaning it has 2 stars orbiting each other. This makes it a unique and fascinating system to study, with potential insights on how multiple star systems behave. But there's still so much we don't know about Alpha Centauri and the universe as a whole. What other secrets are waiting to be uncovered? But what does this discovery mean for the search of extraterrestrial life? Does it improve the likelihood of discovering life outside of our solar system? And what other mysteries does Alpha Centauri hold that are yet to be uncovered? These are only a few questions that continue to intrigue both astronomers and space enthusiasts alike. With ongoing advancements in technology and research, who knows what else we may uncover about our nearest stellar neighbour, Alpha Centauri. As we learned earlier, Alpha Centauri is, by cosmic standards, the nearest star to our planet. But exactly how far away is this star system? The answer is mind-boggling. A staggering 4.37 light years. The flight from London to Sydney, which is around 10,500 miles away, could be completed more than 15,000 times before it equaled the distance needed to travel to Alpha Centauri. Now let's think about this in terms of idioms. Have you ever heard of the expression "a million miles away"? Well, in the case of Alpha Centauri, that's not too far off. It's actually more than 25,000 times further away than the Moon. which is considered just around the corner in astronomical terms. It is astonishing to think that a spacecraft launched in 1977 called the Voyager 1 spacecraft is the farthest object from the Earth which was built by humans. It's now more than 14 billion miles away from us, far beyond the orbit of Pluto. However, even at a distance, it only takes around 21 hours for the signal to arrive on Earth. While this may seem like a lot of time to facilitate communication, let's put it in perspective. You would be required to drive at the speed limit of 60 miles per hour for more than 233 years to travel the same distance as Voyager 1. That's almost as long as the United States has been a country. But compared to the distance of Earth to Alpha Centauri, 14 billion miles is just a drop in the bucket. Remember how we said it was 4.37 light years away? Well, that's about 25 trillion miles. It would take more than 75,000 years for Voyager 1 to arrive at Alpha Centauri if it were traveling in that direction. That exceeds the life of human civilization as a whole. It's amazing to think how far we've come in terms of space exploration, but also how much further we have to go to reach the stars. The question is though, why is this distance so crucial? Well, it presents a huge challenge for space exploration. It will only take 54.6 million kilometers to send a spaceship to Mars, but we're still trying to figure out how to do it. Imagine how much more difficult it would be to send one to Alpha Centauri. Ever been curious about the close-up appearance of Alpha Centauri A? Let us paint a picture for you. It's a yellow star, just like our Sun, but slightly larger and brighter. Picture yourself on a planet that revolves around Alpha Centauri A. What would the sky look like? Would the hues and lands be any different? These are a few of the questions that have long piqued astronomers' curiosity. Alpha Centauri A is actually the largest of the 3 stars in the Alpha Centauri system. Its mass is 1.1 times that of the Sun, and its distance from Earth is roughly 4.37 light years. This means if we could travel at the speed of light, it would take us over 4 years to reach it. But as you know, Alpha Centauri A is not alone. It has companion stars, Alpha Centauri B and Proxima Centauri. Even though Alpha Centauri A and B are actually 2 independent stars, they are so close together that they seem like a single point of light in the night sky. But that's a topic we'll discuss later in this video. For now, let's focus on Alpha Centauri A. The possibility of habitable planets being present on this star is the most intriguing fact about it. Because it is similar to our Sun, it is thought to be capable of supporting life as we know it on Earth. The second star in this 3-star system, Alpha Centauri B, has a mass of about 0.9 times more than the total mass of the Sun, and a surface temperature of around 5,300 degrees Celsius, making it a bit smaller and cooler than its counterpart, Alpha Centauri A. Alpha Centauri B, with a radius of more than 800,000 kilometers, is nevertheless a tremendously huge object in spite of its lower size. But that's not all that's fascinating about Alpha Centauri B. The closest approach between this star and its companion, Alpha Centauri A, occurs roughly every 80 years, due to the slightly elliptical orbit that the star has around its companion. This gravitational interaction can have important effects on the planets orbiting around them, potentially influencing their habitability. Additionally, Alpha Centauri B is a main sequence star, which means it is at the peak of its existence and undergoes nuclear fusion to convert hydrogen into helium. It's about 90% the size of our Sun and has a surface temperature of around 5,500 degrees Celsius. Although it produces just approximately 5% of the light that our Sun does, it is nevertheless sufficiently bright to be seen with the naked eye from a dark place. Another exciting thing about Alpha Centauri B is the planet orbiting around it, named Proxima B. The size of this planet, which was discovered in 2012, is comparable to the Earth's. However, it is relatively closer to its star, completing an orbit in only 3.2 days. While it may be a little hot to support life, its discovery shows that there are other planets out there in our galactic neighborhood. and there may be more yet to be discovered around Alpha Centauri B. Take a look at this picture. The third star in the system, Alpha Centauri C, can be found as we go further away from Alpha Centauri A and the second star, Alpha Centauri B. This star is also called Proxima Centauri. Despite being the closest to Earth, at least in astronomical terms, Proxima Centauri is only visible with a telescope and has only been known to astronomers for a little over a century. It is a red dwarf star, meaning that it's much smaller and cooler than our own Sun, with a surface temperature of only around 2,700 degrees Celsius. Despite its diminutive size, Proxima Centauri has been observed to be a very active star, with frequent flares and outbursts of high-energy radiation. Being the main sequence star, Proxima Centauri, just like the Sun, is still turning hydrogen into helium via nuclear fusion reaction, acting as a main source of Proxima Centauri's energy. It has a luminosity of 0.17% of the Sun and is naturally producing energy at a much lower rate than the Sun. But there is a catch. Proxima Centauri will eventually outlive the Sun. While our star has an approximate main sequence lifetime of 10 billion years, out of which remains 5 billion years, Proxima Centauri will live for more than 40 trillion years, which is why it is fair to conclude that Proxima Centauri can be the escape star for us when the Sun dies down. That is, if we manage to find a way to reach it. Despite it outliving the Sun, Proxima Centauri will also meet the same fate as our star. This means that when its abundant hydrogen supply for fusion finally exhausts, it will die, lacking enough mass to become a black hole or a neutron star, eventually turning into a white dwarf star. Red dwarf stars like Alpha Centauri are most common and are scattered all across the galaxy. For instance, our Sun. However, they are smaller and lower in temperature than our Sun, with temperatures ranging from about 2,200 to 3,500 Kelvin, which is about half the temperature of our Sun. They also emit less visible light than our Sun, which makes them appear reddish. The habitable zone of planets around red dwarf stars is relatively closer to the star than that of a Sun-like star, which is another difference between the Sun and the Proxima Centauri. This is because red dwarfs are less luminous, and their habitable zones are located closer to the star, where temperatures are suitable for liquid water to exist on the planet's surface. The closeness to the star does, however, provide certain difficulties for life to exist on the planet. Stars like Proxima Centauri are more active than Sun-like stars, which means they emit more ultraviolet radiation and X-rays. Over time, these high-energy particles might strip a planet's atmosphere away, making life on the planet's surface untenable. This can also cause a buildup of ionized particles in the atmosphere, which can create a strong electric field that can further strip away the atmosphere. In addition to the high-energy radiation, red dwarfs are also known for their frequent flares, which are jets of radiation that are released from the star's surface. These flares can cause intense bursts of radiation, which can be harmful to life on a nearby planet. The frequency and intensity of these flares can also vary greatly from one red dwarf star to another, making it challenging to predict the conditions around any given red dwarf planet. In 2019, a colossal flare was recorded in the Milky Way, which emerged from Proxima Centauri. It was a plasma eruption, which was more intense than any flare that has ever been recorded in space. However, the very first flare from Proxima Centauri was observed in 2016, and according to a few astronomers, was so bright that it could be spotted with the bare eye from certain sites on Earth. Despite these difficulties, some researchers think that life may still exist on planets revolving around red dwarf stars. Some of these planets may have thick atmospheres that can protect them from such high radiation, which can protect them from high energy radiation, or they may have strong magnetic fields that can shield them from the solar wind. Other planets might be tidally locked, with their other side towards the star, resulting in more stable surface conditions. When comparing Alpha Centauri A to other stars in the system, there are several factors to consider. Their ages are a significant consideration. According to estimates, both Alpha Centauri A and B are older than our star. Both of these stars are around 6 billion years old. In contrast, Proxima Centauri is much younger, with an age estimated to be around 4.85 billion years old. Another factor to consider is the distance between the stars. The Proxima Centauri star is much farther away from the other two stars than the two largest stars, which are spaced apart by around 23 astronomical units, AU. To put that into perspective, 1 AU is roughly the distance between Earth and the Sun. The three stars offer different opportunities for potential habitability. Both Alpha Centauri A and Alpha Centauri B are larger and brighter than the Sun, which could potentially lead to a greater likelihood of habitable planets. The near proximity of the two stars' trajectories, however, raises the possibility for unstable orbits for any extra planets in the system. On the other hand, Proxima Centauri is a much smaller and cooler star, but it does have one known planet in its habitable zone, Proxima B. Proxima B is much like our planet in that it is rocky and has high hopes for hosting life, but it also experiences tremendous radiation from its star, making it potentially impossible for any future life to exist. Proxima B has been a center of attention for space enthusiasts, astronomers, and scientists alike, since it could be a potential planet to harbor life. Let's take a closer look at what we know about Proxima B. Firstly, Proxima B, although very close to its star, is still located within the habitable zone, which means it is at the right distance from its star for liquid water to exist on its surface, which indicates life in all its forms. This possibility is certainly intriguing, and recent research has shown that microorganisms such as bacteria and archaea could potentially survive on the surface of the planet. The possibility of habitable planets being present on Proxima Centauri is one of the star system's most intriguing features. A group of astronomers revealed the existence of the Proxima B planet which orbits the star in 2016. It is located within the habitable distance from the star, where conditions may be ideal for water to exist in the liquid form on the surface of the planet. This is because it is potentially an ocean world, and where there is water, there could be life. The most intriguing question about Proxima B is whether it can harbor extraterrestrial life or not. Despite its relatively close proximity to its two companions, Proxima Centauri has a much wider orbit and takes about 500,000 years to complete a single revolution around the central binary pair. Can you imagine how life would be on a planet that orbits Proxima Centauri instead of the Sun? With its frequent flares and intense radiation, life as we know it would face some serious challenges. But with new technologies and advancements in space travel, who knows what possibilities the future may hold for exploring and potentially colonizing worlds beyond our own. Astronomers have gathered many similarities between Earth and Proxima B. However, their distance from the stars is a major difference between the two planets. Proxima B orbits very close to its star, only 0.05 astronomical units away, shorter than the distance of Mercury from the Sun. But shouldn't it be a fiery hell if Proxima B is located this close to its star? No, because Proxima B receives only 60% of the proximal Centauri's energy, which means protein life could possibly exist on this exoplanet. Many astrobiologists claim that there could be intelligent extraterrestrial life on the planet. Perhaps aliens who have adapted to extreme conditions by building underground cities, or microorganisms could hide themselves from deadly radiation by burying themselves in deep bodies of water. But as with all things, there are challenges that any potential life on Proxima B would have to overcome. For example, Proxima Centauri is smaller in size and cooler than the Sun, which means that Proxima B, just like the Earth, is likely to be tidally locked. This means that one part of the planet will always be facing the star, while the other side will be in darkness. This could lead to both sides of the planet having very different weather and temperature, making it difficult for complex life to survive. However, microorganisms may be able to tolerate these conditions. Moreover, Proxima Centauri is a highly active star, producing flares and radiation that could potentially strip away Proxima B's atmosphere, which is crucial for supporting life. Despite these challenges, scientists are still hopeful that Proxima B may be a suitable planet to harbor life. What is the reason for this optimism, you may ask? There is a chance that primitive life could coexist on Proxima B, especially in regions where liquid water and an atmosphere are thick enough to withstand extreme conditions that could provide protection. In fact, Proxima B's proximity to Earth makes it an attractive target for further study, as it may be possible to observe the planet's atmosphere and surface in greater detail in the future. But what exactly is Proxima B like? Well, the exoplanet is about 1.3 times heavier than Earth, and takes just over 11 Earth days to orbit its star. Although the planet's temperature and atmosphere are yet unknown, Future telescopes like the James Webb Space Telescope may be able to find evidence of extraterrestrial life, such as the presence of oxygen in the atmosphere. Overall, even though Proxima B's harsh environment and high temperature may make it unsuitable for complex life like that found on Earth, it nevertheless represents a tantalizing potential for the discovery of extraterrestrial life. Discovering extraterrestrial life on an exoplanet will remain a mystery unless humans find the way to travel the distance of 4.3 light years. However, hopes are high that if water can exist on the planet, so can some form of microbial life. Scientists believe that Proxima B is safe from radiation due to a strong magnetic field, and they are planning to explore their theories with the help of a special European telescope. It's difficult to avoid imagining what it would be like to set foot on Proxima B's surface as we continue to research and investigate the possibility of life there. While this is still purely hypothetical, let's take a moment to imagine some possible scenarios. What if, after a breakthrough discovery and years of planning, a group of astronauts finally succeed in their mission to reach Proxima B? Imagine this. They set out on their journey, which takes years, as they traverse the vast expanse of space. But finally, they arrive at their destination. And the moment they set their feet on the mysterious land of Proxima B, they are met with a world they have only speculated and daydreamed about. The rocky terrain is reminiscent of deserts on Earth, but the skies above are a deep shade of red, and the stars are unfamiliar. The first thing that will challenge their adaptation journey will be the planet's gravitational pull, which will be slightly stronger than that of Earth. This makes movement more difficult, but they quickly adapt and begin to explore their new home. Depending on which side of the planet they are on, they will experience a tremendous shift in temperatures between the star-facing side of the planet and the one that is in darkness. This means that any human settlement would have to be carefully located and designed to take this into account. Something exciting will happen as they further explore this galactic planet. They will find traces of microbial life on the planet in the form of microorganisms and other creatures. This is an exciting discovery, and they set about studying life forms in more detail. The astronauts will gradually establish a small town on Proxima B, employing cutting-edge technology to build a livable homestead that can resist challenging environmental conditions. Proxima B does not come without its challenges though. The weather on the planet can be unpredictable and deadly, and it is vulnerable to severe radiation from its star. But the pioneers who have chosen to make this their new home are resilient and resourceful, using their knowledge and creativity to overcome these obstacles. As time goes on, the settlement on Proxima B grows and thrives, exactly what they are trying to accomplish with Mars. Perhaps new discoveries are made, such as hidden underground caves or vast oceans beneath the planet's surface. Maybe the settlement becomes a hub for further exploration of the universe, as humans push ever further into the unknown.